Assalamualaikum. Welcome to chapter 6, magnetism. Basically, we are going to learn about magnetic field, magnetic flux, and also magnetic force. So what is a magnetic field? It is the region or area around a magnet where a magnetic force can be experienced. So the magnetic field can be represented by drawing a line we call as magnetic field lines or magnetic flux. So these are the examples of magnetic field around a magnet and also a conducting wire. So the first diagram is a magnet with two poles, north and south pole. So the diagram or the lines right here to show the magnetic field around this magnet. Meanwhile, the next diagram we have a conducting wire with current on it. Then we put few compass around it to detect the direction of magnetic field around the conducting wire. Instead of using compass, we can also use iron powder. We sprinkle iron powder around the conducting wire, and we can see the iron powder making a circular lines around it to show there is magnetic field exists around the wire. So if we want to find the magnetic field strength at certain point or certain distance from the magnet or from the wire, we can find the magnetic field strength, and the unit will be Tesla or T. In chapter 3, we have learned about the electric charge and also electric field produced by it. So if this electric charge move, they will produce electric current. So when there is electric current, the electric current can produce magnetic field around it. So there will be two fields around the conducting wire, electric field and also magnetic field. So based on this diagram below, we can see a conducting wire with current flows in it. So the currents flow from positive terminal to the negative terminal. And at the same time, there is also magnetic field on this wire. Okay, bermaksud ada kaitan di antara electric charge, electric field, electric current dan juga magnetic field. So when there is electric current on a conducting wire, there will also a magnetic field around it. When it comes to magnet bar, if we use magnet bar, then we know they have two poles, north and south. Like poles, north with north or south with south, they will repel each other. Meanwhile, opposite poles, north and south, will attract each other. So by using these bar magnets, we can also determine the direction of the magnetic field lines. Okay, so you can also sketch. Okay, the magnetic field lines will come from the north pole and then it will goes into the south poles. When they are repelled, so there will be neutral point right here, neutral lines, where the magnetic force is zero between these two poles. So make sure you know the direction of magnetic field lines when there is two poles. Based on the previous slide, so I've shown you that to find or to determine the magnetic field, we can use these two examples. First, by using a bar magnet, and second one by using a conducting wire. So when we use bar magnet, there will be no problem because we know whether the magnetic field are going to repel or attract since we have information about the poles. But when it comes to current carrying conductor or the conducting wire, we need to use rules, okay, hand rules. Instead of using bar magnet, magnetic field can also be produced by a current carrying conductor such as wire. So how to determine the direction of magnetic field? It depends on the direction of current on the conducting wire. So look at on this diagram, these two diagrams. First, diagram A, we have a wire with no current. So what happened is, when we put the compass around the wire, the compass directed to one direction only. Then when there is current in the wire, let's say it flows upward, the direction of compass, it circulates around the current carrying conductor. Okay, so how to determine the direction? We can use right hand rule. To use the right hand rule, you need to grasp the wire with your right hand. Okay, so let's take a pen or pencil as our conducting wire. Okay, bayangkan ini adalah conducting wire. So grasp the wire, genggam. Make sure that your thumb directed upward. Okay, actually the direction of thumb depends on the direction of current. Ikut arah current. Okay, if the current is upward, then our thumb is directed upward. If the current is directed downward, then we are going to hold the wire like this. Okay, our thumb will follow the direction of current. Okay, next, what is the direction of the magnetic field? It's based on the 4 fingers right here. Okay, so for example, current move upward, so I hold it like this. Bila saya pusingkan ataupun saya curlkan my 4 fingers ni, okay, dia akan tunjuklah arah magnetic field clockwise or anti-clockwise. Okay, kalau current ke bawah, okay, it will shows like this. Okay, you need to try by yourself. Okay, so that you will understand. Next is you need to understand the direction of current using these 2 symbols, X and also dot. Okay, so first try to imagine that we have a wire with the direction of current going upward. Okay, and then your eyes is here. Kita tengok daripada pandangan atas, upper view. So what you can see that the current will out of the page ataupun masuk ke dalam mata awak tu. Okay, or you can also take an example of a paper. Bayangkan ada kertas. Okay, letak atas meja. And then you bayangkan ada conducting wire letak kat atas kertas. Tengok daripada atas. Okay, maksudnya current tu out of the page. Ataupun kalau current tu is into the page, so arah current masuk ke dalam kertas tersebut. Okay, so why do we need to use these 2 symbols? Because it's much more easier for us to determine the direction of magnetic field. Okay, katakan kita tengok pada pandangan atas, so arah current keluar macam ni, kita gunakan simbol dot, arah current keluar. So bila arah current keluar, you can use your right hand rule. Okay, keluar tu maksudnya you punya thumb ni menuju ke arah mata awak. Okay, they directed to your eyes. And then curlkan you punya 4 fingers ni, you akan nampak the direction of magnetic field is anti-clockwise or counter-clockwise. But if the symbol for the current use is X, okay, maksudnya contohnya kita ada wire, arah current ke bawah. Okay, so you tengok pada atas, arah current ke bawah ataupun into the page. So we use symbol X. Okay, kalau into the page maksudnya you kena you punya thumb ni keluar daripada mata. Dia macam ni. Okay, ataupun ambil kertas, masukkan dalam kertas, dia into the page. And then you curlkan you punya 4 fingers tu, you akan nampak dia akan clockwise. Okay, you need to try by yourself. Okay, kalau tak try, you tak akan nampak macam mana nak tentukan arah magnetic field by using your right hand rule. Okay, remember that your thumb ikut arah current. Meanwhile, these 4 fingers will determine the direction of magnetic field around the current carrying conductor wire. Okay, so there are few cases. Let's say we use a single wire, satu sahaja wire yang kita gunakan. Okay, so ambil contoh yang first, diagram A. So let's say our eyes is here and the direction of current is like this. Okay, so daripada pandangan atas kita akan nampak yang arah current tu dia keluar daripada kertas. So you can use your right hand rule to determine the direction of magnetic field. And the second diagram, the direction of current is into the page. When we look daripada atas. So the direction of current will be into the page. Okay, so we can determine the direction of magnetic field around the wire. Okay, if you still confused or you do not know how to determine the direction of magnetic field, or maybe you don't know how to use the right hand rule, just let me know. Okay, I will terangkan lagi in our Telegram group. Okay, then what if we have two parallel straight wire? Okay, so it depends. First situation, if both current are in the same direction. Okay, contohnya macam ni. Okay, so we know that kalau digunakan dot symbol ni, bermaksud current is out of the page. Okay, so let's say ini adalah wire 1 and then dia menghasilkan current I1, and this is wire 2, it will produce I2, current I2. Okay, bayangkan ada dua wire, and then these two wires has the direction of current yang sama, which is both of these wire produce current that is out of the page. Okay, ataupun ke arah mata kita. And then by using our right hand rule, we know that the magnetic field are going to be anti-clockwise. Dua-dua akan anti-clockwise. Then dia punya resultant direction akan menghasilkan bentuk macam ni. Okay, kenapa kat tengah-tengah ni tak ada kosong? Sebab dia akan cancel out. Satu ke atas, satu ke bawah. So nanti kat tengah-tengah ni dia akan cancel out lah the direction of magnetic field. Meanwhile, if both wire, let's say I1 and I2, if both wire produce current that is into the page, okay, so the resultant direction of magnetic field will be like this. Okay, kenapa? So bila dua-dua masuk ke dalam page, into the page, current into the page, by using our right hand rule, dua-duanya akan produce magnetic field that is clockwise. Okay, so gabungan magnetic field dekat kedua-dua wire ni akan menghasilkan resultant direction like this. If the two wires has current that is opposite direction, so the resultant direction of magnetic field will be like this. Okay, ni situasi yang kedua. Wire 1, I1 is out of the page. Meanwhile, wire 2, I2 is into the page. So, what will be the resultant direction of the magnetic field? Okay, first, kita kena tentukan satu-satu lah. Okay, kalau wire yang pertama ni, current keluar daripada page. So, the direction of the magnetic field lines will be anti-clockwise. Meanwhile, for the second wire, the current is into the page. So, the direction of the magnetic field will be clockwise. Hence, the resultant direction will be like this lah. Bila kita combinekan, nanti dekat sini semuanya bergabung. So, it will produce a resultant direction of magnetic field like this. What if kita terbalikkan? Okay, I1 is into the page, I2 is out of the page. So, I1, it will produce magnetic field that is clockwise. Meanwhile, I2 will produce magnetic field that is anti-clockwise. So, it will produce resultant direction like this. Okay, just now we use a wire, sama ada single wire or two parallel wire. What if we use a circular loop? Maksudnya besi, gegelung besi. Okay, so current can flow on this circular loop. But what will be the direction of magnetic field? Okay, so what you need to do is, you kena try to hold the circular loop at all point. Maksudnya, kalau you ada circular loop tu, okay, let's say I have a wire like this. Okay, bentuk circular loop lah contohnya. Saya akan pegang dekat setiap position of this circular loop to determine the direction of magnetic field. Okay, so arah thumb ni ikutlah arah current yang flow on that circular loop. So, dia akan menghasilkan magnetic field around the circular loop. Okay, yang ni kalau your first one ni kalau dia dalam keadaan melintang. Yang ni kalau dia dalam keadaan menegak. So, what you need to do is genggam pada setiap gelung tersebut, setiap bahagian gelung untuk menentukan arah magnetic field around it. Okay, Yang ni kalau single loop, satu saja loop. What if we have many loops, so we call as solenoid. Okay, solenoid ni sebenarnya ada satu gegelung besi. Okay, so asalnya adalah satu besi panjang yang boleh mengalirkan arus. So kita gulungkan dia. So how to determine the magnetic field on a solenoid? First, kita akan determine the direction of current. Okay, so let's say the direction of current daripada sini, dia akan mengalir, pusing, and then keluar dekat sini, arah current I. Okay, so as usual, we use the right hand rule. Kita akan genggam pada setiap gegelung wire ni. And then, macam ni dia letakkan satu cardboard dekat tengah-tengah wire ni. So that we can determine the direction of magnetic field lines around the wire. Okay, so saya ambil yang bahagian ni lah. Bayangkan you pegang, using your right hand, you grasp this wire at this point. Okay, so you will see that the direction of magnetic field around it is anti-clockwise. Sebab itulah kat sini dia anti-clockwise. Tengok daripada pandangan atas lah. Okay. Ataupun digunakan simbol dot. When we look from the upper view, and then we use the symbol dot. Maksudnya merujuk kepada bahagian ni. Okay. So, the magnetic field around it is anti-clockwise. Kemudian bila current ni masuk pula ke sini, okay, yang ni kita gunakan simbol X. Okay, so bila gunakan simbol X, dia akan rotate clockwise. So magnetic field around this wire is clockwise. So dia akan repeat lah on the same wire sampai dia keluar dekat wire kat sini. Okay, so daripada pandangan atas ni, kita summarykan dia jadi bentuk macam ni lah. Okay, maksudnya current keluar dekat sini, masuk kat sini. Kemudian dia akan sambung dia keluar kat sini, masuk kat sini, keluar kat sini, masuk sini, and so on. Okay, daripada this diagram, we can find the resultant magnetic field on this solenoid. You akan nampak bila kita gabungkan all the direction of the magnetic field lines at the center will be directed to the left. Okay, maksudnya nanti yang ini akan jadi north pole, yang ini akan jadi south pole. Okay, yang penting you tahu gunakan simbol dot dengan X ni, you understand what does it mean. Okay, from that you can use your right hand rule to determine the direction of magnetic field lines around the current carrying conductor or conducting wire. Okay, don't forget to practice until you understand about these magnetic field lines using right hand rule.